We're on the lower gun deck. The cannon ports, the gun ports are actually bigger down here. So in actual fact, when we take off the sill, which kind of the last timber that goes in forming the shape and sealing off the gun port, which is also a big piece of oak, and I can take that off and then I can see the framing timbers underneath the sill. So I'll just see if I can do that. A heavy piece. When this is off, I have a cross section of the timber from the sill, which I can measure the tree rings on, and then underneath we actually have 3 framing timbers. I have only worked there where I need to get the tree ring, so I haven't removed much conservation material or original material anywhere else on the surface. So I've literally, I'm being as minimalist as possible just to be able to get a view of the tree rings, which was one of the main sort of desires in the project and also in the collaboration with the museum here, that the analysis should be as non-invasive as possible. And so this is as non-invasive as you can get if you really want to be able to get the tree ring sequence out of these timbers. So they're already cut in this cross section, and so then all I'm doing is cutting one little sort of line across the rings. I'm making the photos just as close up as possible. Basically, I'm really just using the camera as a microscope. I've prepared the end of this plank. So this plank is basically, it's cut to make space for the gun port, and so I can see the cross section through the tree. And so I have just cleaned it with first just rubbing a bit with a sponge with water to clean off the worst of the conservation wax, and then I have dried it up and then just kind of pared very carefully to expose the actual tree rings, and the wood is very solid underneath there, underneath the actual surface. And then, especially when the tree rings are very narrow, I have rubbed in chalk, like just sort of ordinary school chalk, into the rings, because what that does is the little powders of chalk falls into the vessels on the wood, and it means that the actual rings are kind of highlighted and much easier to see them. So I'm just copying over the photos that I just made. You can see them on the screen here. So we have just been photographing at one of the cannon port, one of the gun ports. So we're more or less midships. So you can see this is the prow of the ship here, and this is the stern, and we're on the upper gun deck. What I'm doing is I am looking at the cross section of the wood, and you can actually see that in the photo here. I can see the tree rings really clearly. And you can see, actually, we're quite close to the pith here. You can see the curvature of the rings. So what I'm going to be doing is measuring every single tree ring along this sequence. So I'm going to join the photographs together. Then I'm going to calibrate the picture using the scale. The first thing I do is measure the tree rings in one big long sequence, not missing any, getting an entire uninterrupted sequence of widths, and there's no chemicals involved, it's just pure analog, it's the widths. One ring, next ring, next ring. Then I get what we call a tree ring curve. So that will be a big long line of numbers which is unique to that tree's growth, but it is a reflection of the climate that was affecting the tree while it was growing. So that pattern I can then match up first with other timbers from the actual Vasa ship, so other of the inner ceiling planks, maybe some of the hull planks, maybe some of the framing timbers. And then I find out what position it belongs to in time, because I will find out where that position, where that pattern matches. Once I've done that, and at this stage I have quite a lot of timbers already analysed for the Vasa, then I start to see which ones are most similar to each other, and that way I can start to define groups of timbers in the ship, and those groups will, to a large extent, reflect groups that trees that came from the same area, same forest perhaps, same region maybe. And so then once I've identified these different groups, I can start to make averages of those, so I have the climate signal for the different groups from Vasa. And already I can see that there are three pretty major groups represented. And the groups do, to a certain extent, align themselves with different functions in the ship. So there's one group that is predominantly the framing timbers, the big squared framing timbers, and there's another group that seems to be predominantly these smaller ceiling planks up in the upper decks. And then when I've made these groups, I can then use the Northern European data set for oak tree rings to try and see where these different groups come from.